let's continue with section 6.3. So on this next one here, we're going to say write 4 raised to the exponent log to the base 4 of 5 as a logarithm. So again, if I was to do that, what I would have here is I would have 4 log to the base 4 is equal to I, all right? And you'll see why I'm using that, because with the ones yesterday we were using x, but these are inverse functions, and you'll kind of see what happens. So again, if I do this, again, I'm going to write it as this base. So I'm going to say log to the base 4. So this base raised to this power. Remember, this power is going to be over here, is equal to this. All right? So if we look at it, this right here and this right here are the same. So what is y? We can say that y is equal to 5. All right? So if you think about it, the 4 and the log 4, so right here, sorry, I want to erase what I have right here. So the 4 and the log 4, this part right here, cancels. All right? So the 4 and the log 4 cancel. All right? So now on this one here, the next one, we're going to write log to the base 8 of 8 as 3 as an exponential. So again, on this one here, we're going to use it as an x. So we're going to say log to the base 8 of 8, 3 is equal to x. So again, this base, so 8 raised to this power, is equal to this. So again, on this one here, all right, since these are the same, that means our exponents are going to be the same. So what is x? X is equal to 3. So again, what this one shows us on this one here is that the log 8 and the 8 cancel each other. So these two right here cancel each other. All right. So this shows that g of x is equal to log to the base b of x, and f of x is equal to b raised to the x power are inverse functions. So example 5 here, simplify. So we have 10 raised to the log 10. Well, it just says log, but remember, if it doesn't have a subscript, we know it's to the base 10. So on this one here, we can say that log to the log 10 of 18, all right? From up above, we found that the log and the 10, the log 10 and the 10 cancel each other, so that cancels that. And what do we have left? We have 18. All right, now they're going to kind of throw other things here at you just a little bit, but again, on this one here, again, we're going to do the same thing. So we're going to have log to the base 4. Now remember, if I want something to cancel, I have 16, but I have an x there. Can you write 16 as something raised to a power? And you would say, yeah, 16 is 4 squared. So if we have that, then we would have 4 squared raised to the x power. Now remember, I can take that and these two, again, a power raised to a power, I'm just going to multiply them. And from what we just saw from the above one, and even from our example, because our example had 4, we know that these two are going to cancel each other. And what am I left with? I'm left with 2x. all right? And then C here, all right? On C, now remember, the natural log is log to the base C. We learned that yesterday. So on this one right here, I can write e to the natural log of 9 is equal to e. The natural log is log of e of 9. So just like above, what's going to cancel? The e and the log e, and what are you left with? You're left with 9. Okay, so that's what that one is. So let's do 6. So find the inverse of each function. So A, we have f of x is equal to 11 raised to the x power. So on ones like this, let me see, why don't I say by definition, of logarithms, we can say that g of x is equal to log to the base b of x. So on this one here, we can say g of x, again, what is our base? It's going to be this one right here. So we can say log to the base 11 of x. All right, so that one's pretty straightforward because it was just by definition. All right. So remember earlier when we were doing inverses, we switched the x and the y. We didn't have to on that one because that one was by definition pretty straightforward. But on this one right here, what we're going to do is we're going to switch the x and the y. So if I do that, I'll get x is equal to the natural log of y plus 6. All right, and remember, so what we're going to do here is we're going to solve for the new y. All right, so on this one here, the way we're going to have to do that is we're going to have to take x, and remember our natural log is our log to the base e of y plus 6. Okay, so again, remember this base raised to this power equals this. All right, I'll say it one more time. This base raised to this power equals this. All right, so e raised to the x power is equal to y plus 6. Now, how do I get that new y by itself? I'm just going to subtract 6. So I can say that y is equal to e raised to the x power minus 6. And that is that one right there. Okay? And then finally, you can use inverse relationships to graph logarithmic functions. So, graph f of x is equal to log to the base 2 of x. So again, by definition, we can say that g of x is equal to 2 raised to the x power. And that was by definition of logarithms. Okay. Now what we want to do is we want to make a table for y is equal to, because again, g of x is just, again, a fancy way of writing y. We always say f of x, but it doesn't matter. G of x, f of x. Okay. So what we're going to do here is we're going to make a table for that. All right. So I'm going to have x and I'm going to have y here. And remember, I like to have you do -2, -1, 0, 1, and 2. All right. So if I work this out, -2, so if I put -2 in for x, remember that's going to give me 2 raised to the -2 power. Remember, I can't have a negative, so I would rewrite that as 1 over 2 squared, which would be 1/4. By the same pattern, I would have 1/2 here. 0, again, anything raised to the 0 power is 1. And then at 1, we would have 2, and then we would have 4. Okay. Step 3, I'm going to plot those points. So at 0, we have 1. At 1, we have 2. At 2, we have 4. At -1, we have 1/2. And we have 1/4. So remember, we're going to have that be an asymptote. That is going to be an asymptote there. Okay. And then we're going to reverse the coordinates to plot log of f of x is equal to 2. And what we're going to see is that is a reflection over the line y is equal to x. So let's go ahead and draw that y is equal to x. So remember, when x is 0, y is equal to 0. When x is equal to 1, y is equal to 1. X is equal to 2, y is equal to 2, etc., etc., etc. On the other side again, when x is equal to -1, y is equal to -1. So there is our line, y is equal to x. All right. Let's go ahead and remember, they like you to kind of put the thing by the graph here. It'll be interesting to see how they have you do it in the thing. All right. So what it says here is we are going to reverse the coordinates. So let me use a different color. I'll use blue this time. All right. So we're going to reverse the coordinates. So we're going to have x. And again, we're going to have y. So y is at -2, -1, 0, 1, and 2. And x is now 1/4, 1/2, 1, 2, and 4. Okay. So if we think about that one there, all right, when x is equal to 4, y is equal to 2. When x is equal to 2, y is equal to 1. When x is equal to 1, y is equal to 0. When x is equal to 1/2, y is equal to -1. And when x is equal to 1/4, so we're going to have something like that. All right. So we know that this one here is going to go like this. Excuse me again. And that is our reflection. So that is our logarithmic function. Okay. Now I want you to kind of think here, did it really do what we asked it to do? Well, let me show you on a couple of them here. And I'll use a different color. I don't use that bright green there. All right. So remember, when I plot a point over the line y is equal to x, I can see if it's the right point because I can move over to the line. So it takes me from this point here, it takes me 1, 2 to get to that line y is equal to x. And then I would go down the same amount. Well, yep, there's that line right there. And you will see it will work for all of the points on this one right here even. Okay, takes me 1 to get to the line. it'll take me 1 to get down. All right. So that's how that one is right there. All right. So hopefully you'll see this when you do your homework. All right. Thank you, people.